Hello everyone. Really happy to see you here on this talk. This is the first day of our JavaScript JCC week, and I think it's been really amazing so far. And I predict that today is going to be amazing as well. So just a reminder, don't forget to join tomorrow's talk from Anton Ilichenko on Introduction to BDD. It's an awesome topic. I think it's going to be great, like every other topic today. And now let me give the word to today's speaker, Stepan. So, Stepan, how are you doing?
Well, I'm a bit tired, but not as tired as you probably.
Yeah. I guess we're all well have been a bit exhausted, but I think it's okay. So, my dear audience, I'd like to ask you to be active, ask questions, and post your questions and answer questions from Stepan, because by the end of this talk, we'll pick the best question, and the winner will receive an Amazon certificate. So, I again present the Stepan with his topic, TypeScript demystified. Good luck, Stepan.
Yeah, thanks. Okay, hello everyone, and again, welcome. But this time from me, we're going to tackle TypeScript topic today, and this is going to be kind of special talk, and I think you will see why in a minute. As like I mentioned, my name is Stepan, and today I'm going to be your mentor, your guide to TypeScript system. We will see how everything works under the hood. We will tackle some complex problems. And you might ask yourself, like, if I'm not using TypeScript or I'm already like know it rather well, what I will get from it. So first of all, today, I bet you will get better idea and understanding of how types works under the hood. And you will definitely look from new perspective at types when you will be working in your project every day. Also, we will break some common misconceptions, some common misbeliefs in today's talk. And in general, I think after this talk, you will become better TypeScript developer. Yeah. So let's unleash unlimited power of TypeScript and see what today I have for you. And yeah, a small disclaimer: this talk is intended not intended like for beginners. Although if you're a beginner, you might get something of that, but I might get you lost somewhere in the middle. So for this case, there will be a recording, so don't be afraid to rewatch it, to play with code snippets, and try to get into this. And for those who get this, that means you are professional. Okay, so at first we will talk about why you should use TypeScript, and actually I would want you to answer this question, and we will see the idea behind type system, how this actually works. We'll see how to actually use operators in TypeScript to create new types based on some other types, and this is going to be probably the most complex one. We also see look at conditional types. Yeah, so why TypeScript? And dear guys, chat, why do you use TypeScript? Can you post some messages like why do you use TypeScript? Why do you think TypeScript is great? Or even if you don't use it, like why would you consider using it? Yeah, let's say any comments there?
Yeah. So, checking. So far, no comments, I guess. Yeah.
Interesting.
See the comments. Add some layer of safety to prevent
Yes.
errors for type safety. Cool for refactors. Less effort for developers in order to catch errors in compile time. Cool predictions.
Nice.
Production standard. So
Yeah. Nice. Oh,
static typing, faster and smarter code completions in IDE.
nice. And no hate speech. Nobody says TypeScript kinda is bad choice. Better use JavaScript.
Nope. So
No.
far, everybody's happy with.
Okay. Yeah. So general idea, like you pointed out, so we use TypeScript because it adds some layer of safety. Because, as you know, with JavaScript you can easily shoot yourself in the foot. So that's why we use TypeScript. But actually, when we use it, I must say, use it. Not always we use it to the full potential. So TypeScript has the same types as JavaScript, and apart from that, it also adds its own type, like void, any, unknown, and never. So about void, we're not going to talk about this today. Any, just forget about this. Don't use any. And today we will focus on unknown and never because they are special. And also we can narrow down types. So we can say that, for example, this variable is not just string, it's string which can contain only hello. The same for number, we can say that variable can contain only 5, and the same for boolean. You get the idea. For function, it works the same way. We can narrow down the signature of the function, so we can say that function accepts some parameter which is number and returns a number. And same for object. We can say that this variable can contain object with property name, which is string. Yeah. So now let's see the first problem we're going to tackle today. So first one, let's define two variables, string A and string B, which simply contain some value. And now, as you can see, we can easily assign string B to string A and string A to string B. Yeah. Let's define new variable. This time we say that this is not just string. This variable can contain value only hello. And as you can see, we can assign string C to string A, but we get an error when we try to assign string A to string C. And again, my question to you, how do you think why we get this error? Because string C is kind of like string, right? So why cannot we assign it? Do you have any ideas, guys? Yeah, please be active and post your thoughts. I'm curious what you think.
Yep, checking those questions.
And if you're not going to post any ideas, I'm not giving you any answer.
Because we have literal type there, we specified type.
Okay, but still it's string. It's string type. Okay. So nobody has any clue. I see. Okay, let's move on. So for the same stuff we have for objects, so let's define some interface. Example A, for example, sorry, which has a name property, and the same example B interface with age property. So now we create a variable, and we say that this variable can be, it's a union. Yeah, I want to like stress this. It's union. It's not or. It's not example A or example B. It's union of example A and example B. And we say that this object will have property age and name. And we create another object, but this time we create intersection. Again, it's not and, it's intersection of example A and example B. Yeah, TypeScript kind of shows like this symbols, but they don't represent like what you used to think, like or and. So in this example, we also can create, as you can see, the identical object. And now when we try to assign intersection to union, we can do it easily, like we don't have any type errors. But when we try to assign union to intersection, we see that we have the exception type example A, union is not assignable to the same intersection. Yeah. Yeah, so we're going to answer this question today as well. And this brings me to the first topic of this talk. It's TypeScript and that theory. And if you don't like understand math, that's no problem. I will explain this to you, what you need to know. So set theory is a kind of branch of math which studies sets. You can think of that as kind of collection of some objects, as a box. So for example, in this case, we have set which contains some values. For example, it contains values 1, 2, 3, right? And we can say that this set includes value 2. Yeah. So the same we can say about like this set does not include value 5. We can also compare sets. So we can say that set 1, 2 is equal to set 1, 2. But in set theory, they don't say that they equal. They say that one set is subset of another. And if we have one set, not identical set, but one set is actually subset of another, but another set has more values, as in this example, we say that it's a proper subset. So from now on, I will refer to this as this will be subset, and this one will be superset. And in this example, it will be always subset. So I won't say proper subset. And also we can say that one subset is not subset of another one. So let's display this graphically. So if we have two sets, identical sets, we can display them as two equal circles because they kind of includes one another. And if we have two not identical but smaller and bigger sets, we can display that A, it's this one, is bigger and it includes subset B. But pay attention please that B set, in this case, it includes not all, but it has values from A. So it does not has any values outside of A. And in the example, when they have something in common, we can say that they overlap. So they have some, for example, in this case, 1, and for B it's 2, it's 4, but 2 is in common, so that this is somewhere in the middle. And the same when we don't have anything in common. In this case, it's going to be disjoint set because they don't share anything. Also, there is two special cases. There is empty set, which does not include anything, and in TypeScript it's represented with keyword never. And graphically, from now on I'm going to display this as this gray circle. And also we have universal set. In TypeScript, it's represented as unknown. The thing about universal set is actually this subset is superset of any other set. So everything, all other sets, is kind of, you can say, inherited maybe, but actually it includes everything in here. So I will be displaying unknown as this rectangle. So how does this work with TypeScript? I think you may guess it. So we can have a set of numbers, and this set includes all the possible cases for numbers. It can be float, it can be number. The same for string. It can be some just chars. It can be values actual. Boolean actually has only two. It can be only true or false. And yeah, and you might think of another like null, undefined, etc. And the thing about TypeScript is all those sets are part of unknown. Yeah, so if we look at our initial problem, so the reason why we cannot assign string A to string C is because string C is subset of string A, and by rules you can assign you can assign smaller, you can assign subset to superset because subset includes all the values from superset, but you cannot do vice versa because superset has more values than subset has. Yeah, I hope that's clear. Let's move on. So with objects, yeah, it's not union and example object, but we need to look at just plain object because they behave kind of differently. So let's say we have object with property name, which is string, and we have object B, which has also name, and it has more properties, age. And now when we try to assign object B to A, it works, right? But when we try to assign object A to object B, it doesn't work. But hold on, you might say, like if we going to, like, if we can assign subset to superset, why cannot we do it here? And the reason for that is actually because for object it's reversible. So the more properties you have on the object, the actually the smaller object is. So in this case, object B, since it has not only name but it has also age, it's smaller. It's smaller subset. And in this case, object A is superset. Yeah, please remember this take about interfaces, because it's important and we're going to need this later. So since like the more properties you add to interface, you kind of shrink down this set of possible values. Let's move on. Let's look at never. So never is actually assignable to every other type. And if you think of this kind of makes sense, because never is subset, kind of subset. Since it cannot contain anything, you can assign anything to something, right? And no type is assignable to never. This also makes sense, because since never does not contain anything, you cannot assign something to that. And it's called bottom type. It's because it's in the bottom because it cannot contain anything. Let's look at the example. So again, let's define our string A with some value, and we declare two variable never. And as you can see, we can safely assign one never to another, no error here. We can even assign never to string. Yes, so TypeScript is compliant here. But once we try to assign string to never, we get an error. So also works. So those two rules works in TypeScript. And yeah, graphically it would look like our string is superset and never is subset. So your take from here should be that never acts kind of like a superset of every other type. So that's why you cannot assign anything to it, but you can assign it to everything. So unknown is the opposite of never. And actually those rules are opposite. So you can assign every type to unknown, and you cannot assign unknown to any type. So this is the opposite of never. And it's called top type because it contains everything. So let's look at the example. Let's define three variables of type unknown. As you can see, we can assign string, we can assign number, we can assign boolean. Also, let's define our string A with some value. And as you can see, we can easily assign unknown values to unknown. So no problem here. This makes sense because you can easily assign one type to another. Like not one type, but same type to same type. And also you can see that we can assign string to unknown. So TypeScript also compliant here. But once we try to assign unknown to string, we get an error. And this also makes sense because unknown is superset of string. So string in this case acts as a subset of unknown. So your take should be that unknown acts as a superset to every other type, and all other types are subsets of unknown. Okay, I hope this is clear. Yeah, let's move on. So now, once we have the idea of how TypeScript works under the hood, how it treats types, now let's look what can we do to create more types based on our types. So in that theory, there is actually 4 operators, I believe. I'm going to show you 4 here, but TypeScript only works with 2. So first one is union. So you can have union of A and B, and you can create bigger type. So in TypeScript, it's represented with a vertical bar. Also, you can have intersection of A and B. So intersection is kind of we can create a type which contains only common values for A and B. And in TypeScript, it's represented with ampersand. And the difference. So this one is not represented in TypeScript, but it's kind of the opposite of intersection. So if intersection is the properties which are common, So with difference, it would be the properties which are different. And complement is kind of different, but instead of taking the property B, we use unknown. So we can kind of get new type, which is unknown minus A. Yeah, if you don't get this, no problem. You don't need this. You need only unknown and intersection. So let's look at unknown. Sorry, not unknown, union. So if we have two types, two sets, 1, 2, and 2, 4, if we create union, we would get a much bigger type, much bigger set with 1, 2, 4. So duplicates in this case are removed, and graphically you would display it as we just like grouped those two types. And in case we want to display intersection, in this case we can have only two. So only 2 is common, so it's the possible type in this case. So let's see how this works with primitives. So let's define our union A which contains string and number. Again, I'm not saying string or number, it's string and number because it's a union. Then we have string A and number A, just simple string and number. And as you can see, once we try to assign union to string or assign union to a number, we get an error. And the reason for that is because union of string and number is bigger set than compared to just string or number. And now I think you might get the idea where you get these errors from, because I've seen this so many times used in project just because people think this variable can contain string or number, but actually it's kind of grouping. And we can assign safely string and number to union because string and number, they are subsets of bigger set. And intersection, I cannot really show you intersection with primitives because there is no primitives which has something in common. So if we try to intersect, for example, string and number, you get never. And this makes sense because never is actually nothing. And as you can see, we have here disjoint set. So we get nothing. And yeah, but as you will see with object, it works differently. So let's also look at some special cases with never and unknown, how types works with it. So if we have, for example, union of string and never, we get string. And the reason for that, again, never is kind of subtype. And once we try to create a union, bigger type, well, in this case, we get bigger type. And what's bigger? Well, string. If we try to do intersection, in this case, we get never. And we get never because what's string intersect, when we try to intersect string and never, we have only never in common, and never is never. Again, we get nothing. If we try to do a union with unknown, in this case we get unknown because unknown is bigger type and string in this case acts as a subset, so we get much bigger type. And string in union, sorry, in intersection with unknown will get string. Again, that's because we get smaller, we get only what's intersecting, and in this case union and string has in common only string, so we get string. Yeah, you don't kind of need to remember this, only we look at this later in the talk. Actually, there is some rules Typescript applies when working with this type, so we will have this at types and later in the talk. Okay, let's define now. Let's see how union intersection works with objects. So we can have interface A with property A and some common property, and interface B, which has just property B and some common property. And now the interesting part, when we try to do union, and yeah, kind of to get this bigger type, we get only common property. Like you can say, what's the matter? Like if we get bigger type, why don't we get all the properties? And the reason for that is, again, remember the beginning of the presentation. The more properties you have on the interface, on the object, the smaller it is. So in this case, in order to make object bigger, we can allow to access only common properties. Yeah, so it's kind of the opposite. So intersection and union works kind of the opposite way. Yeah, sometimes confusing, but what can I say? What can I say? I hope this is clear. Let's move on. So also this union, it's kind of recursive, because if you have different types for common properties, you can see, so in the end, union is also applied to this common property. So as I said, intersection would work the opposite way. So in this case, if we try to intersect A and B, we get smaller type, but since smaller types means more properties, we get more properties. We get A, B, and C, and common property. Yes, so it also works recursively. So if you try to have different types for some common properties, you will get, in this case, never, because if you try to intersect string and number, you get never, because they don't have anything in common. Yeah, I hope this is clear, and I hope I don't lost many audience till this point, because this is kind of confusing. Yeah, so now I can finally answer the issue which we had at the beginning. Why cannot we assign union to intersection? And I think you can already answer this yourself, because since intersection is smaller type than union, you cannot assign it. So you can safely assign intersection to union because intersection is smaller type, but you cannot assign union to intersection. Again, I hope I answered this question. Yeah, and let's get to the most complex part of this talk. And yeah, if you thought that was complex, believe me, what you're going to see here is much worse. But anyway, we need to talk about this, since this is how TypeScript works. So we can also have a conditional types. So let's, for example, define some type is string, and we say if world extends string, in this case, write to this type true, otherwise false. But I want to point out that this extends is misleading. Yeah, it came from OOP, but actually what it says, how you should read it, is if things on the left is subset of the thing on the right. So in this case, we can say that is world is subset of string. In this case, yes, it's subset. So we get back true. The same works for union. So if we have union of hello and world, and we ask if this is subset of number, in this case, we get false. But pay attention that we got false only once. We didn't get false union false. Yeah, and that's the reason for that is actually TypeScript works differently with conditional types depending either it's generic or not generic. So we can also ask TypeScript if, for example, object with shape, name, and age is subset of name. And remember, the more properties we have, the smaller object is. So in this case, it's true because we have name here and here, and this object is bigger. Like not bigger, smaller actually, but it has more properties. And if we try to swap them, we get false because this object is kind of superset of this one. And so the condition doesn't work. And yeah, so how it behaves with generics. So in case you don't know what generic is, it's kind of function. So this signature is kind of function, and this t is kind of parameter to the function. And we say if this parameter which we will pass to this generic is subset of string, in this case we want to get back this type, otherwise we get back never. So is string, now we can call this kind of function and pass something a. And as you can see in the result, we get a because a is subset of string, and if we pass now 5, we get back never. So you might say, like, what's so special here? Well, the thing is, TypeScript applies some rules when works with generics. And first rule, first set of rules, it's called identity laws. Actually, there is, I believe, 12 maybe of them in set theory, but TypeScript applies only 2. So first is a set in union with empty set resolves to itself. And second one is a set in intersection with the universal set also resolves to itself. Now let's look in the code. So we have string and we try to union is with now we get back string. So first rule works, and the second rule also works because when we have string and we intersect it with universal set, we get back this type, the same type. So this works. The second set of rules called idempodent law rules, and it says that a set in union with itself resolves to itself, and a set in intersection with itself also resolves to itself. This is kind of easy actually, because if you have, again, union with itself, you get itself, and if you have intersection with itself, you get itself. So this kind of how TypeScript removes duplicates. Yeah, so let's look at the example of those laws, how TypeScript applies those laws. So let's say we have a type not nullable. Yeah, and this is not mistake. Actually, in TypeScript we have non-nullable, so that's why I chose different name, just to demonstrate you the example. And we say if the type is subset of null and undefined, so in this case we want to get back never. Otherwise we get back the type. Yeah, and now the interesting part, if when we pass union of null and string, as you can see, we get back string. Why so? The reason for that, if you remember the rules from previous slide, is when we have string in union with never, we get back string. So TypeScript actually applies those laws when he works in conditional, he works with types. So that's why never acts as a filtering. And you might say where I might use this type, just for the sake of example, you might have some kind of function which filters out nulls. Yeah, it's generic function. It accepts array of some values, and this array can contain t, null, and undefined, all set of those. And in result, you want to return not nullable. So how can we do this? We simply filter out. We say if our value does not equal not strict null, it means also not undefined. We want to get the value. And also we need to define this type guard for this filter, otherwise we will get type error. So TypeScript understands that our value is actually of those type. And now let's try out. We define array with value 1, null, and undefined, and then we try to, when we call the function, as you can see, we get back number. Yeah, so this is kind of the example of how can you use this type. But now the question is, how does union behaves in generic? So first, if we have union of values, does TypeScript go through each element and applies the check, or TypeScript checks everything as a whole type and just returns it back? And turns out default behavior is the first one when TypeScript goes in generic over each type in union, and this is called distributive conditional type. So let's look at the example. We define some generic, and in this case we say that t extends unknown, like t is subset of unknown. In this case, this is always gonna be true because unknown contains everything. And in this case, please give us the array of this type. And now when we pass a union of string and number, as you can see, we get union of string array and number array. So under the hood, it works like TypeScript goes through string. It checks if string is subset of unknown, correct. it returns string, and then it also checks number, and since it's also subset of unknown, we get back number. So that's how we got this result. And you might say, what if I don't want this behavior? What if I want to treat this type as a whole? Well, it turns out you can. Yeah, sorry. You should also get take from this that distributive conditional type is kind of distributes the check. So you can think of this as a loop. So if you have a union, TypeScript will go through each union and applies the rules. Yeah, now back to how to check, how to use another behavior. And the answer is you need to wrap your type into square brackets. In this case, TypeScript will use non-distributive behavior. And as you can see, if we pass union, we get actually array of this union. Yeah, so I hope this is clear. Now let's give you some examples so you don't think that all this kind of just some nerdy stuff. So let's say we work with API and we have a type success. So when we make a call to API, we get some kind of request ID, we get type success, and we get some values. And also we can have failure because you know that API something can go wrong. And in this case, we get also this similar object where we can have request ID, we have type, and we also have different, but this time different property error. Let's say that we want to have a union of this. So our API response can contain both of those values. And TypeScript allows us to filter out using if. So if we check if our response is success, as you can see, we get what we expected. So we have value, we have type, and we have a request ID. But let's say, what if you want to apply some type manipulation to this union? And yes, in TypeScript, those typing is called discriminated union, and you can actually Google this. There is a section in TypeScript documentation about this. Now, what if you want to kind of omit some values from success and failure? Well, in case you're not familiar with omit is kind of a filter. If you pass some object to omit, and as a second parameter here you pass keys, in the result you get another object without this key. Sorry, not object type. And once we applied omit, you can see that actually we get some errors here. Like not errors, but you can see that our type safety is gone. Even though we checked for success, we got only type here. We don't have our value. And if you look at the resulting type, you can see that it's actually just type union of type success and error. So what was going on here? And the answer is TypeScript actually used non-distributive behavior here. It took success and failure union and applied omit to this. So how can we solve this? Now we know that in order to trigger distributive behavior, we need to use generic, right? Let's use one. So we define distributive omit. It will accept T, and also it will accept keys. So key will be the collection of keys of this interface. And we use this check simply to trigger distributive behavior. We could also says T extends unknown, doesn't really matter. And then we says like this is always going to be true, and we simply call omit with T and K. Now let's use it. So when we pass success, union of success and failure, we can see that everything works. And the reason it works because we trigger distributive behavior. So you can see in the result we have omit of success and request ID, and also it's union of omit failure and request ID. Yeah, this was hard. So what should you take from this talk for those who survived? So first of all, types are sets, and you need to think of them as collection of something. So this is one of the most important takes of this. The more properties you add to interface, it actually shrinks the interface. Also, this vertical bar is union. It's not or operator for types. and ampersand is intersection, it's not and. And also you need to understand that TypeScript applies some rules when it works with types in conditions. So it removes duplicates types, never it filters out, etc. And by default, conditional types, when you work with union, it applies distributed behavior. So yeah, congratulations, you did it, you survived. So I hope it was interesting for you. And now, if you have any questions, post them in the chat. Now I'm going to check if we have some questions. Yeah. Okay.
So Stepan, will you check for the questions? Okay.
Yeah, I'm checking. Let me check, because I didn't see any chat. I need to go through the chat. But yeah, guys, please don't post any thanks, because the chat jumps and I also always get at the bottom. Yeah, you look smart showcasing some crazy types for your colleagues and laugh in 1 week when no one understands what is there. Yeah, actually, when you work with TypeScript, you always have no idea how this works. What do you think about using JSDoc or write the JS code with DTS typing instead of using TypeScript directly in order to skip transpiling? Yeah, this actually is a kind of hot take, because if you somebody who, for those who don't know, like this, it's not trend, but the creator of one of the framework decided to go to JSDoc instead of TypeScript. And his name is Rich Harris, and this kind of he discussing this because he likes when he jumps to not to definition, but rather he jumps to the source code. And in this case, I can agree. I also don't like this when I need I want to go to the source code and look at I want to go and look at the source code, maybe make some modifications, because I love to go to that, not modules. But I hate this step as well. But what can you say? That life is not fair. So I think in this case, JSDocs may leave, but I still don't think it's worth the trade-off of TypeScript. Okay. Regarding JSDoc, does transpiling takes too much time to consider that option? It's not about transpiling, it's more about where you go if you press this command click. So it's whether you go to the source code or you go to the type definition. So maybe TypeScript can also maybe fix this, I don't know, but who knows? Okay. Yeah, in the beginning there was I'm not really getting this question from Rustam. It's
I guess it was in your presentation, Stepan, when in the beginning in one of your slides where you had a union which resulted in a set of 1 to 3.
Yeah,
but
so
on slide 45, I guess it was the same union, 1, 2, and 2, 3,
yeah,
and
it was not union. So the thing is, in first example, it was union with U, and in second example, it was intersection, the opposite. It was like down. So that's the reason. Yeah, so let me check other questions. It's kind of feature of juniors to make more bad code, which you will refactor in some time. Funny. Yeah. I think that in JavaScript, conditional operators, if else, are more comfortable and writable than TypeScript conditional operators. Yeah, you see, the problem with TypeScript types is there's actually a proposal for that, but they are expressions. If else is so ternary is expression, and if else is a statement. And the problem with TypeScript right now is they don't allow you to use statement. There is also some kind of wrappers for TypeScript which allows you to do that. I remember I investigated this topic, but I don't want to try to do this because when it's going to lead to more complex code. But you can Google this. There is actually if else for types, although you first will need to write this if else, then you need to transpile it to TypeScript, and then you need to transpile TypeScript to JavaScript. Another overhead. Well, yeah, lots of comments. Thank you, guys. How do you think, should we cover our types with unit tests? We have logic in types, so it can help with bugs in types. Well, we had a talk yesterday about about unit tests, and I'm not sure the chat will be available, but I also posted my ideas there. So if you use TypeScript, like, depending what your aim is, I don't think you need to test types in unit test if you use TypeScript. But if you want to sleep well at the night, otherwise, yeah, there is a proposal for JS type annotation. Will it be game changer or counterpart for TypeScript? It's not going to be game changer because it's types annotation. So if you see, this is kind of, they try to bring JS doc into JavaScript. That's all that types. So I also checked this, and I don't really like that, but at least they're trying to do something. Yeah, thank you guys for your comments. Does TypeScript has switch case? In generics, no. It supports only ternary, and that's why people don't like going deep into conditional, because if you will see some type, for example, there is typefast and other utility type libraries for TypeScript. If you check their typing, they have like this nested ternary operators, so they don't have. What do you think about that we start to spend more time on type dealing or covering with types instead of just writing basic type? Sorry. Well, yeah, I think I get this. Yeah, so the way I work with TypeScript is I don't just use types for the sake of types. I try to kind of prevent myself shooting in the foot. So if I understand that type can help me avoid some issues, for example, I can give you an example for one of my projects. So what we had some enum, and this enum was a collection of some types of elements. And the thing was that when you added new type of the element, you had and I'll add some kind of thing to that. And so the problem with that was, yeah, so you need to remember that. So what I did, I managed my types this way. So once you added new element to enum, you got errors in all of those 5 files. File and you can okay, next. I think that it's kind of feature which will born hundreds of questions during. I'm not sure I get this.
I think it means that using this feature will bring more question rather than value.
Yeah, but it may be a question to switch case. Yeah, I think TypeScript is complex enough. I don't know if we need if else there, because it will be itself another programming language. I mean, to just code types. Is it still easy to read code when we cover a lot with types? Well, it depends. You see, like, you can also make mistake in types, and you need to think of your types the way you also write business logic. So, for example, if you have one type and you have some depending types, so this way you can kind of infer from this first type. But if you don't need some complex logic there, so for example, if you edit first type, you don't want errors in the second one. So in this case, you can use contract development when you have similar types. Since TypeScript use duck typing, you can easily define two identical types and work from there. Is this session would be available offline? Yes, there will be a recording. Should we still use private type in TS at the same time with private type in JS? So the thing is, I believe TypeScript will do it this way, and maybe actually the newest version of TypeScript actually compiles to the private type. I'm not sure, but I think this makes sense. If you use private in TypeScript, it will actually compile to the private in JavaScript. Yeah, some people asking in YouTube chat. Yeah, I will switch to YouTube in a second. Just lots of questions. Where is any in the hierarchy of types? Is it superset of unknown? Yeah, so the thing with any is any doesn't exist in math theory. So any is it acts kind of like unknown, but it actually disables all type checking. So you can think of this as unknown, but it's kind of special case. Please don't use any. You can do better. Do you think there will be a browser support for types in the near future? Well, I think no. Can we combine JavaScript and TypeScript files? I mean that we have some JavaScript file where we have some code and we wanna to combine to TypeScript file where we have code. Yeah, I believe we can, but this will work only when you import JavaScript in TypeScript. But you won't be able to import TypeScript code into JavaScript unless you have some compilation step and it will resolve it. But generally, yes, you can use them both. Okay. Yeah, and actually in TypeScript config, you have this stuff, allow.js. This should help. What should TypeScript do in the future, in your opinion, to be better than now? Well, I think the problem with TypeScript to be better is backward compatibility. So, for example, I don't like how enum works. Yeah, remove any. Actually, if they remove any, this is kind of one of the things which will break backward compatibility. You can you can start project with strict mode and disable any, so no problem here. And any actually allows you to migrate to TypeScript. Yeah, become native for browsers. Yeah, actually, I would love like TypeScript to be kind of not superset of JavaScript, but actually to be run. So the thing I don't like right now about TypeScript is how they work with enum, because all the type system in TypeScript, it's structural, it's duck typing. But when it comes to enum, it's somehow nominal. I don't know why they made this choice, but actually, if you watch the interview of the creator of TypeScript, he kind of regrets this. He says that this was a bad choice, but nevertheless, now I don't know if they can kind of. I would like to see that they converted enum to structural typing as well, and generally make enums better. Okay, let me check another. Let me check YouTube. Is there any way to use OR operator in this, you said that most people using union as OR operator. I'm not sure I get this. Like, you mean OR type? Well, you see somehow you mean you want to get type this or this or this. Somehow union works in this manner like OR, but it's not just OR, it's more than that. So you can get bigger type which consists of this. So how you treat it, it could be OR, it could be AND. So I don't think there is like kind of this OR. Do you have any recommendations for sharing types between front-end and backend? Yeah, if your backend is written in Typescript, you can use Typescript test query, I believe. Oh, TRPC is called. So TRPC is actually the thing which, when you use write code in the API, it will also produce a client which you can use on front end to call backend with type inference. And in case you want to share the type, the way we did this is if it's monorepo, then there is no problem. But if it's not a monorepo, you can have a separate package where you can define your types, or better, what you can do, you can define OpenAPI documentation, generate type on OpenAPI documentation, publish it to NPM or your private repository, and then you can install this packet in front-end and backend and use this. Yeah, actually, there's answer that there is actually already a packet for this. Yeah, so I believe I answered all the questions. How TypeScript compiles to binary code? Oh, I have to disappoint you. TypeScript does not compile to binary code. Yeah. So I think let's give you guys a few minutes if you have any other question. I mean, compilation process. I'm not sure. I don't think it compiles in binary. It compiles in like on other levels. You mean maybe how it works in CPU? So it's whole different talk. How CPU uses compiler to compile code.
I think in the meantime, Stepan, while we're possibly waiting for a couple of new questions, could you think and pick the best question that you like so far?
Yeah, let me think. Because there's lots of questions. Should it be only question or comment? It could be just a comment, right?
Well, I guess nomination was for the best question, I guess.
Okay. Okay. Actually, this is kind of a tough one. Can I do this offline?
Well, yeah, I guess.
Yeah, anyhow, we can contact the person, right? Unless it's YouTuber.
Yeah, I guess the winner will post the winner in our YouTube comments, and we'll wait for him
Actually,
to contact us. Or
give me a second. Give me a second. What's your favorite arch enemy song? Can I pick this question? Yeah, when are you going to make for us the next conf about TypeScript? Is there any plans with dates? Andriana, we will let you know. I see everybody wants this certificate. Okay, I think it was nice question about how we should, do you think, how we should spend time writing code or writing tests? I think this one from Rustam.
Okay, Rustam, congratulations, you're the winner. So yeah, I think we're gonna contact you and provide the certificate to you. Okay, guys, I think we're out of time. Thanks a lot for your questions. Thanks a lot for your attention and interest in this topic. Let me give you another reminder that tomorrow there's going to be another topic from Anton Ilchenko on introduction to BDD. So waiting for you there. Stepan, thanks a lot. This really has been a wonderful topic and a wonderful talk. Personally, I learned a lot from you from this speech. So thank you very much.
Thank you, guys. I hope you still want to be programmers after this talk. Hope I didn't ruin anybody's programming life.
Okay.
See you.
Thank you. See you.